Hello everyone, so now we will do the quality of service remaining thing. Whatever is left we are going to do that one. So if you remember, in our previous class we done one lab by using the class map, policy map and the service policy by using the modular quality of service CLI. This technique we used to do the lab. Let me show you. This is the lab which we done, and we test the packet. We change the DSCP value. This is the map. This is a technique we use. So now let's continue the remaining topic. So the main important topic is we have the shaping and policing. We have shaping and policing. Just we need to remember, if you see this diagram, with this one you can easily understand. We have the traffic. This is the traffic in the y-axis, and this is in x-axis we have the time. And if we see, this is our bandwidth utilization. Sometime it is going above the level. This is our limit. Above this one is not allowed. Actually this is only the limit which we buy from the ISP. So if this limit is going above and below, so whatever the unit is going, whatever the bandwidth is going above this level, that need to be removed. We can remove, or ISP can drop directly. So how we can remove? So we have two techniques. We have one technique, we have shaping. One technique is policing. Shaping we are going to do in the enterprise network. We are going to do this one, shaping. Shaping means just we will, let me show you with the graph, you will have the idea. This is the shaping. So in the shaping, what we are doing, we are not dropping this traffic. This is the extra traffic, extra congestion we have here and here. So we are not dropping this one. We are doing this one. We are putting this traffic in the queue, and we are allowing them to pass through the interface of the router depending upon the priority. So we are not dropping that one. We are putting in the queue and we are maintaining the level. That is nothing but shaping. If you go for the policing is nothing but ISP is going to drop that one directly. That is nothing but policing. If you have this is above level, they will just drop this one. They will drop. If you see here, whatever the traffic is above that level, he dropped that one. That is known as policing. So traffic, shaping, policing can be used to control the traffic rate. They both measure the rate of the traffic through an interface, taking the action if the rate is above the configure limit. This is our configure limit. Traffic shaping buffer any excess traffic so that overall traffic stay with the desired rate limit. So we will buffer that one. We will put in the queue and we will maintain that one. We will maintain that traffic in the shaping. Means in the shaping we are not going to drop that one. We are going to maintain the desired rate limit, and we are buffering that traffic, and we will allow depending upon the priority in the shaping. Whereas in the policing, just we are going to drop that one. Drop the excess traffic, enforce them for the specified rate limit. We have this rate limit, we will drop if any traffic go above. So in the real scenario, ISP is doing the policing, and in our enterprise network we will apply the shaping. So we will maintain the traffic, we will not send. Example, what I want to say, this is our router. Example, this is our router. This is connected to ISP, internet service provider. And if you see here, maybe your traffic is coming here. Imagine you have here maybe 200 Mbps speed. If you are sending above this one 200, maybe if you are getting 300 Mbps speed, because this is, imagine this is 1 Gbps interface. So maybe your team, whoever is working in your office, they are sending a lot of traffic. They are accessing the internet, different websites. They are sending lot of traffic. So that traffic will come here and it will go here. If you are having the 300 Mbps, it will go 300 Mbps only. But when he reach to ISP router, they will check and they will drop the 100 Mbps. Only they will allow 200 Mbps. That is policing. But here what we will do, we will not send extra traffic. We will send only 200, means we will send only 200 Mbps. We will use only 200 Mbps. If the traffic is getting more, what we will do, we will do buffering the traffic, and we will maintain in the queue, and we will allow one by one. That is nothing but shaping. So we will do one lab for the policing. And if you see this diagram, with this one you will have more idea what we are doing here. Here we are classifying and marking. We are checking that one and we are marking this traffic is more important, this traffic is low important. After that we are sending the traffic, and then we are applying the shaping. If we did not apply the shaping, the ISP is going to drop that traffic, he is going to do the policing. So if you see here, we have the policing here. If we did not do any shaping, we will have the traffic will be dropped. So in simple words, just remember, first of all, what is quality of service? Quality of service is nothing but giving priority to the traffic. Giving priority to the traffic because our router, switches and firewall don't know about priority. They will not give any priority to any traffic by default. We need to tell to router this traffic is important, give the high priority. So we are configuring that one. First we will select the traffic and we will mark this is high or this is low. So this is a quality of service. We will prioritize the traffic. After that we have two terms. One is shaping, another is a policing. Shaping means we will buffer the traffic and we will allow them. We will not exceed the limit. That is shaping. And policing means the ISP will check whatever limit he give. If we receive the above limit traffic, they will drop that one. So now we will do one lab. So you will have more idea. We will do one policing lab, but in our syllabus we don't have any lab. If we know only theory, that is sufficient, but anyhow we will do one lab. So with that one you will have more idea. So what we will do, we can use GNS3 or EVNG. Here I done in the EVNG. Anything we can use, no issue. So I will use here GNS3. I will create new project here. Let me give name as a quality of service. And here we will use two router. We can take number of routers, but for simplicity I will take two router. Imagine one router is our router, one router is a ISP router. So imagine this R1 is a our router and R2 is a ISP router. If you want to change the name, we can change ISP. So this is a ISP and this is our router. We can connect here. Let me connect. I will use fast Ethernet 0x0 to fast Ethernet 0x0. And what we can do here, we can put one loopback and we can put the IP schema. I will take IP schema is 192.168.12.1, or if you want to take the public IP something, you can take 200.1.1.1 this side here, and the other side we will take 200.1.1.2. Your wish, you can use anything, but we need to remember whenever we are configuring router, the interface which is directly connected, facing interface, that should have the same network. This interface, the R1 interface F0x0 is connecting to ISP interface F0x0. These two interfaces should be in the same subnet. If it is in different subnet, it will not communicate. So we need to take care whenever we are using any IP. In real scenario also we will have the same subnet. If we buy IP from the ISP also, they will give one IP. You need to assign to your company router one IP. Other IP, that is the same subnet, they will assign to the ISP router. And let me take here one loopback here. I will write loopback 0, and we will imagine this is a Google server 8.8.8. Okay, so this is a scenario. We are going to use this scenario in our lab. So imagine we will send more traffic from here. So ISP is going to drop the traffic here. So let me start the router and let me take the console of the router and let's write the configuration for this one. Same configuration as we done in our previous class, we are going to do that one. Here we will have some different steps. I will show you that one. Let me open this one also. We will use policy map, same map, class map, policy map, whatever we use, we are going to use same thing. Okay, so let me take first of all the notepad so we can write the configuration. So I will take notepad here and let me write the configuration. We can give any name. Let me write the name policy or quality of service lab. In bracket we can write which lab we are doing, policing lab. Okay, so this is a lab. R1 configuration. R1 means our core. Imagine this is a core router. Let me draw here. In the real scenario we will have like this one router. In the real scenario I am saying, in the real scenario we will have here ISP1, and here will be ISP2. and this will come, it will come to the layer 3 switch. Depend company to company, it will change, but generally many organization is having this type of structure only. And from here we will have that access layer switch, and then here we will have the PCs are connected here like this, all the client PCs, server, we will have so many switches. I am writing here only 2 switches. In this level you will have many switches, and you will have here ether channel. Here also you will have so many link ether channel, and here also you will have the ether channel. In enterprise network we will have these types of network. And your traffic, example, your traffic will go from this direction to this direction like this. If anything go wrong here, automatically your traffic will switch from here to here. This way they will go. Generally in the real scenario we will have like this. If your company is big, they will take the 2 ISP connection in your organization, and one will be primary, another will be backup as a secondary. If anything go wrong here, automatically traffic will switch to here with the help of HSRP. HSRP we have in our syllabus, we are going to do HSRP also, no issue. So now what I want to show you here, this router is our router. This is router is our router. This is a ISP router. This here we will have ISP router. So ISP will configure here. He will configure the IP. He will give /30. /30 means we will have the 4 IP. One will be network ID, one will be broadcast ID. We will have only 2 usable IP. So one IP they will assign here this side, other IP they will assign here, and we will create the default route. We will forward all traffic to ISP. Same thing we will do here also. And after that, what we are saying here, quality of service. So what we will do here, this ISP is going to apply the quality of service. So when we send any traffic from here, they are going to drop that one. So let's see, this is just I give the example in the real scenario how we will have. So in this router, this is a router we have here, we can apply the quality of service, and after that we can pass the traffic, but ISP will apply here and they will drop the traffic if we are getting the excess amount of traffic, if he is getting the excess amount of traffic. And here you will have the different VLAN, all that one. Anyhow, let me start the configuration. R1 configuration. So R1 configuration, we will write enable config t host name R1, and then we will write interface fast Ethernet 0x0, and then I will write IP address. What is the IP we are planning? 1.1.1 255.255.255.0, and we will write no shut. This is a R1 configuration. Okay, and what I will do, we will create one default route also, because as I told just now, we will create default route to send the traffic towards the ISP. So I will write here IP route 0.0.0 0.0.0 200-1.1.2 means what I will say. Let me take this pen. Imagine this is our network. Here our guys are sitting here. Okay, so whatever traffic is getting to our router, I am saying router R1, check in our routing table. If we have that route, okay, good. If we don't have, forward that all traffic to this interface, this IP. This is a ISP. So forward that all to ISP. ISP router is a big router. He is having the more routes, or ISP is the responsible. He is going to take care about that routes. So what we are saying, 0.0.0 with any IP, 0.0.0 with any subnet, forward here. That's all. So this is a default route we created here. Now what we will do, after that we can do the configuration for ISP, but in the real scenario we will not touch ISP router. In the real scenario we will not touch ISP router, but here for lab purpose we will do the configuration. So imagine now I am a ISP. What I will do, I will do here, let me paste and rename this. This is ISP configuration, and the router name also I will give ISP, and IP here this one, and we don't have default route. Maybe ISP can give default route to any other router, but we don't know, and we no need for us to know where they are forwarding. That is ISP headache. So now I will create this. Imagine this is a Google server. Here we have Google server, so all the traffic is going to ISP. From ISP it will go to Google. So this is only the basic configuration what we need to create. This only we will do in the real scenario. ISP is going to do this one. So now let me copy paste this one in the R1. So I will go in the console of R1. This is a R1. I will paste here all the configuration. Then what I will do, I will copy this configuration for the ISP and I will paste in the ISP router. This is the ISP router. Just I will paste the configuration. No error, nothing. Everything is okay, working perfectly. Now what I can do here, let me go here. I will go here. I will ping here, or let me make the screen big so you will see this. I will write here ping 800 8.8.8.8. I am checking I can ping the 8.8.8 or not. Yes, 8.8.8 I can ping. Reply is coming. If you see here also this one is working. Let me ping again. So everything is good. If I want to ping continuously, I can ping also, like I want to send more traffic. Imagine what I can do. I can connect maybe 10 PC. What I can do, let me show you. I can connect 10 PC here. I can connect one switch here. Example, what I need to do, I need to send more traffic to the ISP. So what I will do, I will connect one switch here. I will connect maybe 10 PC and I will access the Google. I will ping the 8.8.8 from this PC, from this PC, from this PC. So I will have more traffic. Okay, I will have more traffic and this more traffic will go here. So ISP will drop that one. But instead of connecting switch and all PC and pinging with all switch, we can do one more technique. I will show you how we can do. We will write here ping 8.8.8 and then we can write repeat, and you can define how many packets we want to send. Example, I will say 8,000 packets. So if you see, this guy is sending 8,000 packets. This packet is going to ISP router. ISP is not dropping anything because ISP did not configure policing. ISP, that is Internet Service Provider, did not configure the quality of service. He did not configure the policing. If he configure the policing, what we will have, they will drop our traffic. So what we can do, if you want to check here, we can check also. What we can do, we can write here debug, but don't do this debug in the, what we can say, debug IP, ICMP, or we can write packets. In the real scenario, don't enable the debug command, because CPU will go high and you will face the slowness in the network. So don't do this in the real scenario. I enable here. If you see here, we are getting here, what we are getting, someone is sending the 8.8.8. Someone is sending, that is destination. So this machine, the ISP router is replying. ISP router is replying to 8.8.8. If you see, source is 8.8.8, destination is 200.1.1.1. So ISP router is replying that, saying that I am sending from 8.8.8 to 200.1.1.1. So ISP is replying. So this CPU will go high. Okay, CPU will go high. Depending upon the router, if you have good configuration router, no problem for ISP. ISP is using good configuration router, ASR 9000 series. They are using very good configuration router. So no need to worry for that one. But we are not paying to ISP to utilize this many, use this much speed. We are not paying to ISP to use high speed bandwidth. Whatever we are paying, the ISP will have the record. He will check if we are using more than what we are paying. So what they will do, they will block. So what they can do, they can configure the policing in the ISP router. So when we are sending more traffic, automatically it will drop. So we will verify that one. So now I want to disable this one. So I will write you all. When you write you all here, this will stop. Okay, I enable the debug, so I want to disable that one. So I write you all. When I write you all, it will stop the debugging. So now it is stop, I think, or let me write here you all. So now we need to look for the configuration. If you see, single packet is not dropped. Even if we are sending heavy traffic to the ISP, we are sending heavy traffic to the ISP router. We are using google.com, we are accessing, we are imagining that we are accessing google.com. How we are imagining? We are pinging 8.8.8 and we are saying 8.8.8 is a Google server, this one. So ISP router is not doing anything. He is allowing us to use that one. And we are using, and we notice here we are not getting any packet is not drop here. If it is drop means you will have dot. If you have dot means drop. So ISP is not dropping any packet. So now we can do the configuration. So configuration is very easy, but in the real scenario we will not do this configuration. ISP guy will do that one. ISP guy will do that one. So if you remember, in our previous lab what we told, we will use class map, then we will use policy map, after that we will use the service policy to apply that one. Why we use class map? We use class map to select the protocol, select the packet, select the traffic. We use class map. If you remember in our previous lab, let me show you. If this one, I think, if you see here, yesterday what we done, what we told, we will use class map. Why we will use? To match the traffic. Okay, identify the traffic to apply special treatment. To identify traffic we will use class map, and we will identify the traffic, and then we will use the policy map to apply the special treatment, and after that we will apply this condition in the interface by using the service policy, as we discussed before. So we will do same thing here also. So what we will do, first we need to configure the class map. So how we will create? We will write class dash map, and we can give any name. We can give ABC, XYZ, any name we can give, but we are doing for the ICMP, so we can write ICMP, or which protocol you want, you can give any name. You can give name, is our wish, whatever we want we can give. Example, I want to give as a CMAP, I can give CMAP also, CMAP. So with this command what I done, I created class map, I give the name as a CMAP. Now I want to match the protocol, so I will write match, then protocol. Which protocol I want to match? ICMP. I am using here ICMP. Whatever protocol you want to match, you can match that one, ICMP. So what we done with this one, we match the protocol, means we selected the ICMP. After that we will use the policy map. So I will write policy dash map, and we can give any name. We need to give here also name. So let me give PMAP. I will give name as a PMAP, means policy map. And here I need to call the class. What we do, first we will select the traffic. So I need to select the ICMP traffic. So I will select the traffic in class map. Which class map? In the CMAP, I use CMAP to select the ICMP. After that I will create the policy map. Any name we can give. I give the name as a PMAP. PMAP, I give name. You can write XYZ, ABC, any name you can give, or your name you can give here. Okay, but I am giving, this is a policy P first letter, and I am writing map. Same thing I give here, C first letter and the map. But here our wish, whatever we want we can give that one. So here I created the policy map, and in policy map we need to call the class. So which class we need to call? We will write class, and which class I want to call here? I created this class CMAP, so I need to call that one here. So what I will do here, I will write here CMAP. So I will write here CMAP. So what I done, I call that one in the policy map. After that I will apply policy. I will write policy. I will give one number. You can give any number depending upon. I am saying that if any traffic is reaching to this one, allow them. If traffic go above this limit, drop them. So we can write policy, and we can define a limit. After that we can say conform action transmit. If the traffic is less than or this much, we can transmit. If the traffic exceed, action will be drop. We can say if the traffic go above this limit, then drop the traffic. Okay, so what we are saying here, just we are defining that one. If the traffic is we are giving one limit. If the traffic is less than or equal, transmit. Above, drop the traffic. After that what we will do, first we done class map. We create class map with the name of CMAP, and in that one we selected the protocol ICMP, and we create the policy map with the name of PMAP. Here we call this class here, means we are assigning the policy, some policy to this class. We are saying this is a limit. We are defining if everything is less than or equal to this limit, transmit. If they exceed, drop that one. And now we need to apply. So apply means we need to go inside that interface. Which interface we want to apply? We will check. We want to apply this interface, fast Ethernet 0x0. So we will give the interface fast Ethernet 0x0, and then we need to apply. How we will apply? With the help of service. So service policy. Then we need to write here input or output. If you see here, this is our router, ISP router. We are standing here and this traffic is going like this. So this traffic is going inside the router, not the leaving. It is not leaving, it is entering the router. So that is nothing but input. So we need to write here input in. So let me write here, we will write here input, and after that we need to define the name. What name we write? If you see here, when we create this policy map, this is the name. So we will write this name here. Okay, no confusion. Let me explain again also. I will repeat one more time, no issue. Let me repeat again one more time. This is only the configuration. Just we will say policy, service policy input pmap. Okay, let me explain again. We have three things. First is class map. Class map. Why we are using class map? To select the traffic. Then we have the policy map. Why we are using policy? To apply the special treatment. Whatever traffic we are selected, we will call the traffic here and we will apply the special treatment. After that we will use the service policy. In the service policy we will apply that in the particular interface. We will apply that one in one interface. Okay, so this is only what we done here. We class map, giving the name as CMap, and we selected this ICMP, match protocol ICMP. Then we write policy map pmap, and we call the selected traffic as a class CMap. Then we put one limit and saying that confirm action transmit, if exceed drop, then go to interface and apply that one. If you are applying to the interface where traffic is going in, we will write input. If the interface where we are applying traffic is leaving that interface, means we will write out here. That's all. So let's do this configuration in the router. Let me go in the service provider router. In the real scenario we will not access the service provider router, but for lab purpose we will do. So as we told, class map. Okay, just write class and press tab, you will get that one. Then any name CMap and match protocol. Match protocol. Which protocol? ICMP. If you want, you can press question mark. You have so many protocol, which one you want to match? For our lab we are using ICMP, but in the real scenario you will check which protocol you want to match. Okay, so we have so many here. This router is supporting so many protocol. Let me exit this. So now I will write match protocol. I will use ICMP. Okay, so what I done, I created only one class, I selected that one, and this router hangs, so we will wait for few minutes. I think this router is hang. Anyhow, because maybe RAM is low for this router, that's why it is hang. We can increase the RAM, but anyhow let's see how we can increase the RAM. We can go here in the configuration, but we need to switch off the router and to increase that RAM. Here if you see 64 MB we have MAB. Let me check here, we have some option to increase the RAM. RAM size is 512 MB, NVRAM is 512 MB. We can increase this, but anyhow now I will not increase because already we configure. So we will wait, maybe after few seconds it will be okay. Now it hang because we send a lot of traffic here just now. So let's wait for a few minutes, or let me stop. So what we will do, we will write match protocol ICMP. So we created the class, then we will write exit. Okay, after that we need to create the policy, that is what we can say CMap we created, right? And we need to create the policy. So how we will create the policy map? Okay, policy map. Class map is finished. Now we will go for the policy map. Policy map we can give any name. So I will write pmap. You can give any name, pmap, and what we need to do, we need to call the class. Which class we need to call? Just now what class we created. If you see here, which class we created this class CMap. So I will use this CMap same here. I am calling that class here. So I am saying the class CMap. After that I need to apply the policy. So I will write policy. I will give any number 12800. Okay, So I apply this one. After that we are saying that confirm, just press tab, automatically it will come confirm action, transmit, and we can say exit action, drop, and then exit, and then again exit and go to that interface, exit again, go to that interface fast Ethernet 0 by 0, and now we need to apply. So we will write service policy, and this is a input, and which interface, that is a interface, no need to write, just input and write the policy map name. So here is the policy map, this is the name P map, so I will put the P map here. That's all, we apply here. Okay, now we can ping. Now we can ping. Before it is working perfectly, but now you will have the drop. See here, you have drop here. When you are exceeding the limit, you will have, your traffic will drop. If you see here, dropping, again here drop, again here drop. When you exceed the limit, ISP will drop. So here drop, again here drop. So this way we can do the policing. ISP will configure this one, and when you are sending a lot of traffic, if your limit is crossed, ISP will drop that one. If you see, whenever traffic is going heavy, it will drop. So this one is known as policing, and the other one is shaping, which we will use in our network, but the ISP will use the policing. So this is a policing lab. So let me show you here what else in our notes. This configuration we do just now, this one, and we can check also with this command, show policing map interface. With this one we can verify also. What we will verify, how much traffic he transmit and how much traffic, that is how much packet he drop. We can check that also. In the ISP router we can check that one. Like this is a ISP router, right? So in the ISP router we can type here show, let me write here, show policy map interface. Which interface? That is F0 by 0. So we will write and press enter. So here we will get that one, how much, if you see 723 packets permitted and 33 packets exceed, so they drop that action. 33 packets they drop, they permit this one. If you see, this is a byte 82422, and they take an action transmit, and this much byte they drop that one. So this way we can do. Now it will increase the value because still it is running. If you check now, it increased the packets. How many packet you have now here? 964, and the drop will 44. If you see, before you have 723 is transmit, 33 packets is drop, but now 964 is transmit, 44 is drop. So this way we can do the lab policing. Okay, so with this way we will finish our quality of service. So let me stop this.